Hello, everyone. I'm Sean Akins, CEO and co-founder of Collaborations Pharmaceuticals. Thank you all for joining us today to learn about the next generation of our core technology, Assay Central, the next generation. We're going to show you how we're committed to using our computational approaches at the company for applications in areas like toxicology, pharmaceutical applications and drug discovery, and also consumer product and agrochemical uses. We'll also show you how we really can apply these technologies to different areas. And we also realize the value of your time today. So we'll try to keep this presentation to as close to 45 minutes as possible. So just before we begin, a few public service announcements. There is a Q&A button in the Zoom application that you have. And we'll accept questions, obviously, via this mechanism. This is probably the best way to do it. So if you could click on that at any time, put your questions in there, and then at the end of the presentation, we will address those questions from the audience. It would be great if you could use that, and please refrain from using the raise hand feature in the software. The Q&A button is the way to go. We'll also be surveying you with a few questions throughout the webinar, so please participate in that and be ready for those. There'll be one at the beginning in about a slide's time, and then there'll be one at the end. And of course, thank you all for attending the webinar today, and we look forward to your questions. I have a little itinerary here, sort of just briefly outlining the kinds of areas that we're going to cover. I'm going to begin by sharing some brief information on Collaborations Pharmaceuticals and the type of research that we do, and obviously development of software. Then we're obviously going to go into our Assay Central part of the presentation, and Kim Zorn is going to provide an overview of the recent changes to Assay Central, as well as a live demonstration of the new capabilities. Finally, we'll present some examples of what we can do with our machine learning services and the applications. And we'll also describe some use cases which may help you and your companies and your research institutes. And here is the poll. Please participate. The question is, does your company currently use machine learning to inform its drug discovery and/or toxicology endeavors? And if you'd like to click on the button and submit, in a few moments, we'll be able to show you the results of that poll. So I'm just going to pause here for a moment while the results come up on the screen. Terrific. So most of you are using computational approaches, nearly 90% of you. It's a priority or somewhat of a priority in your drug discovery or toxicology endeavors. And only for a very small percentage, you're not using machine learning. Great. Thank you very much for taking part in that poll. So I'd just like to give you a little bit of an overview of who we are briefly. I founded the company in 2015. It's really to build on my 25 years of drug discovery and machine learning expertise. I had a large number of collaborators, and that was really the inspiration for trying to form the company and name it Collaborations Pharmaceuticals. We're actually located at NC State University campus here in Raleigh, North Carolina, and we have 3 labs, and we're able to do lab work as well as computational work as well. Currently, we have no angel or VC funding, so that gives me complete control of the company and direction. And so we don't have to go with the whim of these organizations. We can pretty much pick and choose what we would like to do. We've been able to fund the company primarily through grant funding from the NIH and Department of Defense, as well as North Carolina Department of Commerce. And we've been able to supplement that funding primarily with doing fee-for-service work with various large organizations. And this grant funding that we've had to date has enabled us to work on a whole array of different drug discovery projects that have then led to 9 orphan drug designations for rare and neglected diseases. And in the last year alone, we were awarded 3 pediatric rare disease designations. So what do we do at the company? Briefly, we apply this drug discovery intelligence that we have alongside our artificial intelligence, the software that we've developed, ideally to develop clinical candidates for rare, neglected, or unmet therapeutic needs. We are essentially a drug discovery company, first and foremost, but we also provide contract services, especially in the area of machine learning, and we have a specific focus around computational toxicology. We focus on early stage drug discovery and hit to lead candidate optimization in the area of drug discovery, pharmaceutical applications, but we also apply our ADME-Tox expertise to other areas such as consumer products and agrochemicals. We also tend to focus on very challenging new data sets for our clients and collaborators. And along the way, we've been able to provide packages, collections of computational models in different areas, as well as develop different proprietary tools to design molecules, enumerate them, and perform retrosynthetic analysis. And most recently, developed tools for de novo design of molecules. Our goal, of course, is to be your partner of choice for machine learning and drug discovery. And hopefully today we'll show you the very latest work that we've been doing. I think where we differentiate ourselves and where we can add the most value is obviously in focusing on avoiding the late stage failure of molecules, whether that's pharmaceuticals or agrochemicals, and also rescuing stalled programs that may be in your pipeline. Others obviously focus on predicting bioactivity using machine learning and computational approaches. We feel that that is really relatively easy. The real challenge is, of course, ADME-Tox and those issues, and those are the real killers. We have obviously over 25 years of experience in this area, so we feel that we can benefit your organizations. And we've obviously consulted for many companies. And as I mentioned, we do work on challenging problems, so that's a specialty for us. Along the way, we've been able to develop a whole suite of machine learning approaches, and one of those that we'll be focusing on today is Assay Central, which is our core technology for curating data, building models, and validating them. And along the way, we've developed collections of models like Megatox, which is hundreds of toxicology and molecular property models, Megatrends, again, a very large number of transporter models, both efflux and uptake, and then Megapredict, which is literally thousands of models that we've developed from Kemble, which allow us to potentially repurpose molecules, whether drugs or natural products. And most recently, we've developed Megasyn, which is our recurrent neural network tools for de novo ligand design. And these can be applied to small molecules as well as large molecules like peptides or proteins. And the final software we've most recently developed using machine learning is UV Advisor, which enables one to predict the UV vis spectra of a molecule by providing the SMILES string of a molecule alone. So we've been able to build up quite a pipeline in the company, and most of the projects that we have going on in our drug discovery pipeline have really used machine learning in some way, shape, or form, either for discovery of the molecules initially or for lead optimization. And our goal is obviously to de-risk these projects and then find partners to take them to the clinic. So without further ado, it's my very great pleasure to introduce Kim Zorn, who's a senior scientist with Collaborations Pharmaceuticals. She joined us in 2017, and she's been incredibly closely involved with Assay Central development since then, really shaped the product and worked with a number of our fee-for-service clients and presented the results of this research at various very large conferences such as ACS, CTAC, and ICRS. And in the process, she's been able to be quite prolific in publishing over 25 papers using Assay Central. So without further ado, I'm going to pass it over to Kim. Thank you.
Thank you so much for that introduction, Sean. As he said, Assay Central has been a huge part of my life over the past 4 years at Collaborations Pharmaceuticals. So I'm really excited to talk to you guys about how we've updated it recently. Now, before we dive though into a live demonstration, I do want to just give kind of a quick preview and overview, as well as just starting with what Assay Central offers recently. Now we have 15 algorithms available to us now, which means we can use just about any data set you can throw at us to create both classification and regression models. We also have multiple fingerprint options, radius options, and bit size options, so you can really customize the descriptors to your data set needs. We also have multiple avenues of user-defined thresholds now. And our software is very accessible via a web browser with a secure login feature. And we have multiple prediction options available as well now, including the ability to predict across a huge swath of models. And we've taken some of the guesswork out of these predictions as well, where normally it would be on you as the user to make sure that your predicted molecules are compatible with our models. We're going to take that guesswork away from you, and we're going to automatically apply the exact same standardization that the models use as well. Additionally, we have this very intuitive web interface that's just easy for everyone to use, not just experts. So when you first arrive at assaycentral.org, you'll see a variety of tabs up in the corner, but you won't have too much functionality until you license the software from us. And then you'll get a unique login, and then you'll be able to actually utilize Assay Central. And the way these tabs are set up is ultimately kind of your order of operations for how you should run everything. You'll start by just uploading files, very simple first step. And you'll use these to generate the data sets that will actually be used to train your models. Once your models are trained and completed, you'll be able to view their performance metrics, and you'll be able to use them to conduct a couple of different types of predictions. And then you can also monitor your training and your prediction status over in the Jobs tab. And if you are given the power, you will be able to set and edit and customize user permissions as well. So as I said, let's start with step one. You'll see this button in your top right corner, and it'll open to this dialog over here at the left. You'll see first and foremost that we can now accept multiple formats of files for upload, either your standard SDF or a comma separated value file, or a zip file for big files, or if you want to upload multiple at a time. So plenty of you will be very excited to hear that if you do use a CSV file, your smiles will be automatically converted to structures. We no longer have to do any guesswork and wonder if those went through properly. You also have the ability to annotate all different types of information about this file, whether it be a project, the target, the measurement type, the source of the data, anything you can imagine. You can also set access permissions. We have 3 different levels, ultimately, if you want everyone to see it, if you want only a few people to see it, or if you want to keep it completely private to only you and a select group of users. Now, your file may have some extra superfluous information in it, though. So we take these files and transform them into data sets. And these data sets have the model necessary components for machine learning. And what I mean by that is we've standardized our chemicals, getting them compatible for machine learning. We've set activity thresholds, for example, and added any other sort of important identifiers to that data set. Now, as I mentioned previously, we have the capability to do both classification and regression modeling, and we have a couple of different ways to specify your field types to get a data set that can do both. Now, if you want to have a classification model, you can use either the single class label, and that just means that this is already a binary column. You can either have already set that threshold, someone else has set that threshold, but it could be either binary or hit call data for this single class label. Or say that you have continuous values and you want to set that threshold, you can use the split on value option. And this is where you as the user are setting that threshold from that continuous data. And then for the regression algorithms, we have this continuous value option. And here we also have the option to log your data. If it is not already logged, we always suggest that you do that before training regression models. And over here at the right, I just have an example of where we have utilized both continuous and that split on value feature to get our classification and regression data inputted. And once you generate your data set, you'll end up with something like this shown on your screen. You'll notice that your split on value column is present, but you also have a new single class label that you have created with that threshold. And here we have either a pink dot, which will tell you that it's an inactive designation, or green for an active designation. You also have lots of other information available at the top right where you can edit the description of that file separately from the original file, kind of double check your actives and inactives ratio based on that classification data. as well as multiple viewing options for this data set and multiple download options. You can also go through and see the log of the standardization procedures that were taken with your chemicals, just to kind of double check that everything is looking good for you. But of course, what we want to do is move on to step 3, where we will train our model. Again, we have 15 different algorithms. We have lots and lots of choices available to you. We also have multiple fingerprint options, as well as you have the ability to set different diameters of those fingerprints. I put diameter in brackets because I just want to warn you that it is actually in radius, but usually when we talk about these fingerprints, we're talking about them in terms of diameter. And again, we have multiple bit folding options as well. Additionally, there's always kind of this trouble with developing a test set for your training set. So we've kind of made that a little bit easier by giving you the option to take your whole data set and split it into an external test set and your training set. And you can set aside up to 30% of your data set as the testing set. After you've trained your models, we can then go and view our performance metrics. We now have this nice feature where our performance values are highlighted on this red to green, low to high scale. So you can just really briefly glance and see how well your model is performing across all of these algorithms. We do still also have ROC plots or R-squared plots for classification or regression algorithms. And you can view either the training or the testing metrics when applied. You can split this all sorts of different ways, and I'll show you a little bit more in the demonstration. And then also a great feature that we've added is you can export everything to an Excel file, so you can easily share everything with your colleagues. And here's just a very general idea of a data set where we've applied all 15 algorithms. You'll see we have our classification statistics over here on the left and our regression over here on the right, again, in that low to high, red to green color scale. Once you've had all your models trained up, you have multiple prediction options. So you can either go to the prediction tab, where you can actually search through the EPA CompTox dashboard by a variety of identifiers. You can draw a new structure, you can modify that structure that you've grabbed from the EPA. And here you can get instant predictions from selected models, and you don't have to worry about saving anything. So if you're feeling a little bit more adventurous and exploratory and you don't necessarily want to upload anything yet, this is the feature you'd want to use. But say you have a vendor library, and here you can generate a result set where you can actually upload that vendor library, have the exact same standardization protocols applied to make it compatible with the model, and that output is stored, and then you can download it later as either an SDF or an Excel sheet. Additionally, if you have a test set, for example, that already has single class data, available for compatibility with a training data set, you can create a validation in these result sets as well. And without further ado, let's go ahead and start a live demonstration. 2 moments. So here I have us zoomed in on just a data set that I have created that has both continuous values as well as single class labels. If you're ever curious, you can always just check out this description. We should always try to keep as much information in there as possible. Again, we can have our download in multiple ways, either an Excel sheet and our SDF, as well as view our standardization protocol and download that as necessary. If we go to this little hierarchy button right here, this is where we can actually start training our models. Because I have everything available to me, it's going to start by default with just absolutely everything. It by default goes to ECFP6 descriptors, 1024-bit folding. But for example, what if I say I only want my regression algorithms and I don't want to do ECFP6, I want FCFP6. We can always have our auto button checked here first, and that's just kind of an assurance. All that is going to add whatever descriptor options you've chosen here. We also, for our more advanced deep learning algorithms, have a couple of parameters that you can customize here to hopefully try to keep from any overfitting, any overtraining issues. So here, I just want to quickly train my regression algorithms. You'll notice I got a nice little green success button. And then I can go in and also do only my classification algorithms and say here, I want ECFP6 because I'm comfortable there. It's my sweet spot. I can also select here, as I said, we can split up to 30% of this data set into a testing set. Let's say for demonstration purposes, I want to set aside 15% of this data set as my test set. And we'll go ahead and start training that as well. Now, if we want to just check and see how everything's going, we can go over to our jobs page. Here, we're going to have our data set listed here, and you can see that some are in created. That just means that they're added to the queue, ready to go, lining up, either running, and this will give you some information on which server and a container. And so if something's not looking right, you can actually contact us and we can do a little bit more troubleshooting and digging in. Additionally, we have done, as in we are completed, and we have a new link to our actual result. So let's go in and check out some of these classification models that we built. You can see down here that we have a few ROC plots because we have our classification algorithms, our nice low to high, red to green statistics spread out across here. We can also view only our test set right now, for example, if we'd like, or we can view everything all together. I personally always like to view the training set first. If we click on any one of these methods, you can also go in and see that we have our training set statistics as well as our test set statistics separately. And we always have our ROC plots as well, training on the left, testing on the right. And additionally, as I said, because we clicked that auto button, we have our descriptors as well as that test set percentage added on to the end of our data set. And just a quick reminder of everything we chose as well. Because we have a test set selected, we also have this split option available. If we go into here, we can actually see what made it into our training set with our little train icon, or our testing set, our little test tube. And we can download this cleaned up model ready file as either an Excel sheet or as an SDF, and it will actually have a new column there that will tell you if it made it into the training set or the testing set in the end. So you can always follow up and check on all of that. And if you're ever curious, oh my gosh, Kim, I don't remember what I made this model from, we have some ways to kind of work your way backwards and actually go to the original data set as well as the original file that created this model. Again, once we have our models, the name of the game is predictions. So let's start out with just this predict tab, where again, we can search through the EPA CompTox dashboard. So say we want to search by tetra. Because I don't have this little fuzzy box over here, it's only going to start out my search with anything that begins with what my search term is. If, say, though, I want to expand it to tetra anywhere in the name, all I got to do is click on this little fuzzy option. And you'll notice as we scroll down that now tetra can be in the middle of our name for our molecule and kind of just give you more options available. But tetra isn't very fun. Everybody loves a bisphenol. So let's go ahead and make bisphenol A our example molecule. Notice because this is stored in EPA CompTox dashboard, you'll get a little more identifier information as well as a link to this compound. But say we don't want exactly bisphenol A, we can modify this compound however we see fit. We have lots and lots of handy dandy tools in this structure drawer. Then we can go ahead and start selecting our models. So here I've already prepared a set of regression and classification models. So we can get our full shebang image and we can go ahead and hit predict. You'll notice that this only takes a minute, and I just want to stress that I am on a standard desktop. I am not even on my really good Wi-Fi. I am working at home right now. So you really don't need to worry about having crazy hardware going on. We have our servers on the benchtop behind us. If anything ever goes wrong, you don't have to worry about calling New York City and waiting on hold for an hour. We can get to that immediately and help you immediately. So again, you'll notice that I have regression predictions. And these predicted values are always going to be based on the data that actually went into the model. So it's always important to kind of remind yourself in your data set name what is actually comprising that model. And it's always important to log your data. For our classification model predictions, it's the same kind of setup you saw with the data sets, where we have this pink for inactive prediction and green for active predictions. You'll also notice that we have an averaging feature. So if you don't really want to put all of your stock in one algorithm specifically, you can start with just what is the overall average prediction, either for regression or classification. Again, though, say you have a vendor library or you have a testing set that goes along with a training set. So for today, I actually have a test set that is the readily biodegradable data set from Opera. And I can just go in here and my quick actions get our prediction dialog going. So here we actually have multiple options for averaging. You can either just select individual for, I don't need to worry about averages. I want to select only a few models that I absolutely have full faith in. You can also select all, say you have 20 models that you want to go after. Give me an average prediction across absolutely all of them. Or my personal favorite, I like to average by name. So this means if you select multiple data sets, it's going to give you an average of just all of the algorithms within those data sets particularly. And that just keeps things nice and clean for me. I already prepared this readily biodegradable training set. So I'm going to go ahead and select that for my predicted model. So we have similar setup for field type. You can select chemical name, you can select a record ID, which is just kind of saying this is important information, but it's not really the name of my chemical. I do want to keep that attached anywhere I go. So here, if I just left everything alone, I would just get some predictions, and I'll show an example of that shortly. But I also have data, and I have it compatible already with a training set. So what I'm going to do is select this as my single class label. Again, that means that it's binary data. And this is how I'm going to generate a validation. So I'm going to go ahead and hit create. And because I have this last checkbox here, it's going to automatically send me into my prediction. But you'll notice I don't have anything going. That's because the gears are turning in the background. So while those gears are turning, I'm just going to go ahead and show you another example. Here, I didn't have that validation option selected. I just have 3 different named data sets. And you can see, so I have 3 different averages, either classification or regression or another classification model. If I want to see any of the individual predictions that went into this, all I have to do is undo my little average slider, and then I can see all the individual predictions for each of my chemicals through each of my models. And you can, of course, download these as an Excel format or an SDF, however you'd like to do it. And same thing, you can go ahead and view any of the standardization steps that went into these predictions. So by now, we should already have our validation ready. And we know that this is a validation because it overall looks pretty much the same as what I already showed you, but there's this new little graph button up here, and that's how you know that your validation has completed. If we go in here, you'll see similar setup to what you've already seen. It's going to be the data set with the method name right after it. But now we have a whole series of metrics similar to what we saw in the training data set. And this can be easily copied and pasted into a spreadsheet, take a quick screenshot, publication ready. And again, you can always go over to your jobs tab and actually see how long all of this is taking. You can see most of these are running in under a minute or 2. Again, I am on my standard Wi-Fi at home, standard desktop computer. You really do not need anything fancy to run these models. So with that, I am going to head back to the PowerPoint. Because now that we've seen a live demonstration, how about we see some applications? Specifically, we're going to apply this to some endocrine disruption data sets. Now, Kim, what is endocrine disruption? Endocrine disruption is a chemically invoked alteration of hormone levels in the body. And this can be really, really bad. It can affect normal sexual reproduction, normal skeletal and muscular growth. And targets of interest include the estrogen receptor, or ER, as well as other targets like aromatase or the androgen receptor. Now, of course, because this is such a big problem, especially in environmental chemicals, there have been calls for novel tools to accurately, rapidly, and cost-effectively anticipate endocrine disrupting effects in chemicals. And this has led to things like the Environmental Protection Agency's Endocrine Disruption Screening Program, which is absolutely amazing, but there are still backlogs upon backlogs of chemicals for testing. And there is this general push to move away from animal testing. And luckily for us, computational methods are really offering a solution and a sweet spot to address all of these problems. But of course, the EPA has kind of already thought about this. A few years ago, they created the ToxCast pathway model of endocrine disruption by ER, where they took all of these ToxCast and Tox21 assays that kind of target different processes throughout the overall mechanism of endocrine disruption via ER and created these agonist and antagonist pathways. And they did this by using over 1,800 chemicals from these assays. And they ultimately generated this area under the curve score. And that will classify a chemical as being either an active, inactive, or inconclusive agonist, for example. And it is important to note that the molecular structure of the chemical actually didn't come into play at all, only these assay results that were already existing. So we kind of thought to ourselves, well, what happens if we want to do this? We want to predict endocrine disruption, and we want to do it from molecular structure alone, because sometimes you don't have this data available to you already. So previously, we've published on using the Bayesian algorithm with ECFP6 descriptors and these probability-like prediction scores to tackle this problem. And we used the same test sets that the EPA used to evaluate that ToxCast pathway model, set of in vivo and in vitro reference chemicals. And we used either all 16 assays as what totaled the agonist pathway, or in a follow-up paper, they actually suggested that maybe you don't need all 16 of those. Maybe there's only a minimal 4 that you need. So we kind of used both those methods and used a majority rule method of classifying a chemical with our predictions. And ultimately, what I mean by that is if more than half of the assays in that pathway predicted it as active, we call that an active classification. So we're kind of showing you a quick preliminary update to that today, where we're going to use 8 classification algorithms available to us on specifically some binary hit call data from these same assays. And we're also going to have an average of all of those algorithm predictions. We are still going to use a similar prediction method with that majority rule, either using 16 or only that minimal 4 assays, and evaluate it with some in vitro reference chemicals. And this is how we're going to kind of see how all of this swath of algorithms perform and be able to identify which one is best suited to predict ER agonism. So here's our first graph. We have on our x-axis just all of our algorithms abbreviated. On the y-axis, we just have a standard frequency count. In our gray bars, we're going to have overall accuracy of predictions. In our blue and red, respectively, we're just going to be having the number of active classifications made by that model suite. Or we're going to have in that lighter column, either true positives in blue or true negatives in gold. So the first thing you can see across here, the first thing that strikes me is our models are really good at predicting active chemicals. And what I mean by that is you'll notice that the active designations and true positives are exactly the same. We're not getting any false positives with any of our algorithms, which sounds super awesome, I have to say. We are having some false negatives that do vary from algorithm to algorithm, but we're seeing support vector classification actually has the least difference between those. It's only producing 6 false negatives here. And that's how support vector classification is also our overall winner and just predicting everything more accurately than the rest of these algorithms. So right off the bat, we're saying, SVC, you're doing really good. We're liking what we're seeing. But again, what if we try out with just that minimal 4 assays? So here, the first thing that strikes me is that we have drastically reduced some of our false negatives, especially if you're paying attention to the random forest algorithm. You'll notice that we're actually cutting our false negatives in half, which is really, really excellent. We're doing this at the cost of a couple of false positives, but we're really only seeing a couple per algorithm. Still, though, we're seeing support vector classification is the most correct overall, the least amount of false negatives, even though random forest had a great glow up for our minimal 4 assays. Support vector classification is still doing the best out of our algorithms for these in vitro reference chemical predictions. So overall, what I want you to take away from this is, again, we can have really high confidence in our active predictions if we're utilizing that entire agonist pathway of all 16 assays. If we're using only those minimal 4 assays, we see a pretty big decrease in instances of our false negatives, and we're ultimately increasing our overall accuracies. And one of the things I really want to stress here is all of the options that are available to you. So you can just start with predicting and using all of the algorithms and see which one is best suited for your needs specifically, because there is no magic bullet. There is no perfect algorithm. It all depends on the data set that you bring forward. I also want to stress that unlike the ToxCast pathway model, where everything is in the public domain, Your data is remaining totally private. It is as private or as public as you want it to be in Assay Central. And additionally, a huge advantage that I see to Assay Central is that we don't have inconclusive scores, which can be really confusing if you're trying to prioritize chemicals and you get ultimately a computational shrug of what you should do. So we have it really clear cut and defined in Assay Central. Additionally, I also just want to say that this applied default parameters. We used only one set of descriptors, and we did that standard majority rule designation. So there are lots of variables that we are going to be altering in future studies, and I highly suggest that you keep a lookout for some announcements and publications coming out of Collaborations Pharmaceuticals. And with that, I'm going to turn it back over to Sean so he can discuss some more of the business side benefits and examples of working with Collaborations Pharmaceuticals.
Thank you, Kim. That was terrific. I'm going to share my screen, and we're going to put up the slides. Here we go. So what Kim's showing you today is very latest Assay Central, and obviously there's a scope for even expanding further. And one of the areas that we're very interested in is data visualization and structure visualization and how we can visualize the activities. So this slide shows some examples of some of our efforts in this area to try to look at ways that we could represent the chemical space of training sets and test molecules, for example. We're showing here T-SNE pots, which have been relatively widely used in recent years. We're using the ECFP6 descriptors here alone to represent the chemistry space of our acute toxicity data set, and our non-toxic molecules in sort of a light blue, and then toxic molecules in red, really to visualize where they're clustered. And obviously we're using a very large drug library called Superdrug in dark blue. So you can see where there are actually pockets of toxic molecules based on this rad acute toxicity data. And on the right-hand side, we have the Merco scaffold, which is another way of representing the molecules, as well as the ECFP6. So just demonstrating where perhaps you can visualize toxic molecules. And obviously going down to the actual individual molecule level, being able to understand features on the molecules that may be toxicophores versus non-toxic molecules. So this is definitely an area that we're looking to integrate in the future. So just to round off, obviously the benefits of working with us, we're a company that's really heavily focused on our data curation quality, as well as model quality, as Kim showed you. We are a very flexible, obviously small company, so we can work on your types of challenges using machine learning approaches that we have available to us. So even if you don't want to license the technologies for internal use, we can use those for your fee-for-service projects and get you the results and hand them over. And we can obviously move quickly as we're relatively small and obviously focused on using these technologies for a whole array of different projects. We've been able to show over the last couple of years a sustained productivity and obviously industry leadership in this field. We've been able to publish over 20 papers in each of the past 2 years, not just over the past COVID year, but the prior year as well. And a heavy emphasis on these publications is obviously on machine learning and both applications in computational toxicology as well as drug discovery. If you're concerned about intellectual property, we've, over our career, have many examples of publications and patents. And over the last year alone, we've been able to submit at least 6 patents or provisionals, both internally as well as with collaborators. And as I mentioned at the beginning, we have over 25 years of experience in computational drug discovery. We've worked with a number of large companies. So we have some client use cases, both consumer product companies. As Kim showed you, we've worked heavily on the endocrine disruption side of things and computational toxicology. We've been able to deliver a whole array of models for one of these companies, which was a multi-billion-dollar consumer product company. This has also led to numerous papers, posters, and talks over the last few years. We've worked with a second company that's a consumer product company as well, also interested in endocrine disruption. And more recently, we've worked with a rare disease company, a large multi-billion-dollar American company, to help them in one of the project areas, designing new molecules and using data that they provided around ADME and bioactivity data, trying to come up with new ideas of molecules for them with improved ADME properties. And finally, we've worked with a small animal model CRO company where we've developed models for them for the target activity, in vivo activities as well. And in addition, most recently, BBB models for them to score their internal projects. So none of this really would be possible without funding from the NIH and the NIHS. So I'd like to acknowledge them. And so we'd be happy now to answer some questions. And please, if you haven't already, put them in the Q&A box. And don't use the raise hand feature. Obviously, it's much better if you can put them in the Q&A and then we can go through them. If you'd like more information around Assay Central, you can obviously go to our website, collaborationspharma.com. If you'd like to try some of the models we've put up on www.assaycentral.org, you're more than welcome to. Obviously, if you would like to talk to us in person, please reach out. And obviously, we'll be following up with a copy of this video for you to look at your own leisure as well. So our next webinar will be in about a month, and we'll be focusing on our generative design using Megasyn. And this is a technology that we've developed in-house, and it will integrate the machine learning models that are developed from Assay Central. And this presentation will be given by Dr. Fabio Urbina. So please watch out for that, and look forward to giving that presentation in about a month. So we will be happy to answer your questions. I think we're also going to have a final poll as well. So let's see that come up on the screen, and that will give us a few moments to put your questions in the Q&A box if there are any. And I also see that there are some questions in the chat box. Here's the final poll. Please respond to that. And we should see the response to that and the answer in a few moments, and then we can go to the Q&A portion of the presentation. All right, so thank you. We have about 80% of you that are likely to recommend your company start using Assay Central. Great, thank you very much. And now we'll be happy to answer some questions. Kim and I here, we can go and look at anything that's coming up in the Q&A. So far, we don't have any questions in the Q&A. Let's have a look in the chat box.
I did notice in the chat box, there was a question around ensuring the security of confidential compound structures. And this is where I will say, I didn't go into too much detail on the actual file upload part, but this is where you can set the privacy of your file. You can set your privacy of the data set that comes out of that file. You can set the privacy of the individual models and the prediction files as well. Every single step along the way, you can be setting the privacy of these files. So you can make them public if you want to. You can make them so that if you have a user login, you can view them. Or you can even set them to be only 5 people can say actually read or have write permissions to any of those files and models. So we do take that very, very seriously, and you can set permissions on a whole swath of files and options there.
Thank you, Kim. All right, if there are no other questions, we would be happy to follow up. If any of you want to reach out, please get in touch with us. And thank you again, Kim, for a wonderful presentation. And thank you all for attending today. I know obviously there's a lot of competing things for your time, but we really appreciate you wanting to listen and learn about Assay Central, the next generation. Thank you all. Have a great day.